Hi folks, we're going to take a look at page 344, number 25A. So they're telling us that these two vectors A and B are perpendicular to each other. They don't give us any indication as to their magnitudes, but it asks us to express the magnitude of their sum in terms of the magnitudes of the original vectors. Okay, so if you look at part C of this question, that's slightly more interesting, but this is the one that was assigned. So look at this one here. Okay, so don't do something silly and say that the magnitude of A plus B is the magnitude of A plus the magnitude of B. Be making up algebra. So let's draw ourselves a picture as a representation. So I don't know anything about these vectors other than they're perpendicular. So let me draw that. So say this is vector A, okay, and this say is vector B. Okay, they're perpendicular to each other. And what I want to talk about here is I want to talk about their sum. Okay, so I'm going to take this and move it over. So here is vector A plus vector B. Okay, and the resultant vector is just joining the tail of the first to the tip of the second. So this represents A plus B. But what's nice here is that I've got a right angle triangle. So if I'm looking for the magnitude of A plus B, I can just use Pythagoras. So that's just going to be the square root of the length of this side of the triangle, which is just the magnitude of A squared, plus the length of this side squared, and that's just the magnitude of B squared. And lo and behold, I've managed to do what they asked me to do. Okay, so I guess if I wanted a formula for the magnitude of two perpendicular vectors, this could act as a formula. But of course, the assumption in this question was that these two vectors were perpendicular. Okay, that's it for this one.